Okay, welcome back again. In this video, we are concentrating on and one more assignment question on partial differential equation, and it is totally based on homogeneous partial differential equation. Homogeneous partial differential equation, and it is very easy. Everybody will get minimum 7 to 8 marks for this question. Look at how to solve this question. You have dou square u by dou x square plus u equal to 0, and you have two initial conditions. By using these conditions, you can able to find out the arbitrary function value. Which value? Arbitrary function values. Okay, so look at how to solve this step by step. First, you can understand what is the first step. Here it is a partial differential equation, and here u is the dependent variable. Okay, and you can find independent variable is only x. But in partial differential equation, what happens? There should be a minimum two independent variables. But here one is not visible. Did you understand this? One is not visible. Not visible in the sense, for example, our body is a dependent variable. Our hands is one independent, our legs are another independent variable. If when we are eating, as I told you so many times, when we are eating, legs are not necessary, right? Isn't it? Okay. Means the thing is that you don't have legs. Okay. Meaning ಏನು ಹೇಳ್ತಂದ್ರೆ ನಿಮಗೆ ಕಾಲು ಇಲ್ಲ ಅಂತ ಅರ್ಥ ಅಲ್ಲ, ಕಾಲು ಇರ್ತವೆ. ಊಟ ಮಾಡೋ ಟೈಮ್ನಾಗ ಕಾಲು ಏನಾಗಿರ್ತಾವ? ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರ್ತಾವೆ, ಅಲ್ಲಿ ಕಾಣಲ್ಲ. ಕಾಣದೇನು ಕಾಣ್ತಾವೆ? ಊಟ ಮಾಡಿದಾಗ ಕೈ ಅಷ್ಟೇ ಕಾಣಿಸ್ತದೆ. ಅದೇ ಥರ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ವಾಯ್ ಇರುತ್ತೆ, ನಾಟ್ ವಿಸಿಬಲ್. ಹೌದಾ? ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ನಮ್ಮ ಹತ್ರ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇದೆ. A partial differential equation with respect to one independent variable becomes ordinary differential equation. A partial differential equation with respect to one independent variable becomes partial differential equation. Then it will become d square u by dx square plus u is equal to 0. Why it is? Since ನಮಗೆ ಒಂದೇ ವೇರಿಯೇಬಲ್ ಕಾಣಿಸ್ತಿದೆ, therefore it will become a ordinary differential equation. The dou becomes d. Then this is a ordinary differential equation. We have already discussed ordinary differential equation in the first model. Okay, it's a homogeneous, again homogeneous ordinary differential equation. What is the standard form there? Standard form is function of d, here dependent variable is u, is equal to 0. There function of d into y is equal to 0 we are writing, right? So we have to convert in terms of function of d. For that, what we are going to substitute here? D square by dx square by capital D square. Then it will become d square u plus u is equal to 0. D square plus 1 into u equal to 0. Okay. Now it is in this form, in a standard form. Then you can write auxiliary equation, that is m square plus 1 equal to 0. We are replacing d by m. Okay, so it's a quadratic equation. How to solve this quadratic equation? M square equal to minus 1, m equal to plus or minus square root of minus 1, m equal to plus or minus square root of minus 1 is iota I. With respect to this, what is the solution? What is the complementary function? Dependent variable is u is equal to c1 cos x, because independent variable is x. c1 cos x plus c2 sin x. This is the solution of only this equation, not this equation. Actually, we want to find the solution of this. Look at, since it is with respect to x, again it is second derivative, okay. Since it is a second derivative, from second derivative, if you want to get u value, you need to integrate twice. One time integrate ಮಾಡಿದಾಗ dou u by dou t dou x ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಸಲ ಮಾಡಿದಾಗ u ಬರುತ್ತೆ. ಅಂದರೆ ಇದನ್ನು ಇಂಟಿಗ್ರೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಎರಡು ಸಲ ಮಾಡಬೇಕು. ಮಾಡಿದರೆ ಮಾತ್ರ ಏನಾಗ್ತದೆ, ನಮಗೆ u ಬರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಅಂದರೆ what is the meaning I am going to tell you is that this is solution of only this equation. If you want to write the solution of this equation, partial differential equation, I want to replace this c1 by f of x, c1 by f of x and c2 by g of x into sin x. In partial differentiation and partial integration, when you integrate, you will get a function of, with respect to x, you will get function of y. Look at one example. If I have dou u by dou x is equal to some x, okay. Here, if I integrate this with respect to x, okay, this will become u. Integration of x is x square by 2 plus, in ordinary integration we are writing it as a c, isn't it? There is a constant of integration, but here we can't write in this manner, because here we have integrated with respect to x, means we have to add this constant of integration as a function of y. Which one? Function of y, we have to write it as a f of y. So therefore, this is not f of x, this is f of y and this is g of y. Hope it's clear. This is the solution of what? This equation. Now solution is over. Our aim is to find out f of y value as g of y value. Okay. So how to find out this? For that you can look at the first condition. Okay. Look at the first condition. This is x and this is y. This u value is this when x is 0. The meaning is u is equal to e raised to 1 by 2 when x value is 0. Okay. Substitute condition number 1. What is condition number 1? U is equal to e raised to 1 by 2 when x is 0. Right? Substitute ಮಾಡಿ ಇಲ್ಲಿ. You can substitute here and call it as 1. U is equal to how much? E raised to 1 by 2 when x is 0. This is f of y into cos 0, g of y into sin 0. Sin 0 is 0, 0 into g of y is 0, cos 0 is 0, cos 0 is 1, 1 into f of y is f of y value is equal to, this is root e or e raised to 1 by 2 as it is. What is f of y value? E raised to 1 by 2 or root e. Okay. Next, to use this condition, I want dou u by dou x. I have only u. You can differentiate u. Differentiate u with respect to x, then you will get dou u by dou x. With respect to x, f of y is constant, write f of y as it is. Differentiation of cos x is minus sin x. Here g of y is constant, sin x differentiation is cos x. Hope it's clear, right? When there is a constant into variable, constant is taken out. Differentiation of cos x is minus sin x. Here g of y is constant, into sin x differentiation is cos x. Then use condition number 2. Substitute condition 2. What is condition 2? Dou u by dou x is equal to 1 when x is 0. You can use here dou u by dou x is 1 when x is 0 minus f of y into sin 0, g of y into cos 0. This value is sin 0 is 0, 0 into 0 is 0, cos 0 is 1, 1 into g of I is equal to 1, or g of I is 1, or 1 is g of I. So finally you can substitute f of y and g of y value in equation number 1. Therefore 1 becomes u is equal to, what is f of y? Root e into cos x. G of y value is 1 into sin x. So this is the solution in case of partial differential, that is to be homogeneous partial differential equation. By using these two conditions, you will get the value of f of y and g of y. Any doubt regarding this? If you have any doubt, you can ask me. Otherwise, you will wind up. Thank you.